Let us now understand chemical reactions of phenol. Reactions in phenol can be classified into two groups. The first one is cleavage of OH bond and the second one is reactions of benzene ring. Click on the corresponding buttons to learn more. Let us understand cleavage of OH bond. The first one is reaction with metals. Phenol react with active metals such as sodium, potassium, and aluminium to yield corresponding phenoxide and hydrogen. Consider the reaction 2C6H5OH plus 2Na gives 2C6H5ONa plus H2, where C6H5ONa is sodium phenoxide. In addition, phenol react with aqueous sodium hydroxide to form sodium phenoxide. Consider the reaction C6H5OH plus NaOH gives C6H5ONa plus H2O. The second one is acidity of phenols. The reaction of phenols with metals and sodium hydroxide indicate its acidic nature. Phenols are stronger acid than water and alcohols because hydroxyl group in phenol is directly attached to the sp2 hybridized carbon of benzene ring. Due to charge distribution in phenol molecule, oxygen of OH group becomes positive. The second reason is due to the higher electronegativity of sp2 hybridized carbon of phenol to which OH is attached, electron density decreases on oxygen. This increases the polarity of OH bond, causes increase in ionization of phenol. The third reason is in alkoxide negative charge is localized on oxygen, whereas in phenoxide the negative charge is delocalized due to resonance making it stable. The fourth reason is charge separation in phenol make it less stable in comparison to phenoxide ion, hence favoring ionization of OH bond. You can see here charge separation in phenol and also see no charge separation in phenoxide ion from the given diagram. Text. In substituted phenols, the presence of electron withdrawing groups enhances the acidic strength of phenol. That's why acidic strength of orthonitrophenol is greater than paranitrophenol is greater than metanitrophenol. This effect is more prominent if electron releasing withdrawing group such as nitro group is at ortho and para positions. On the other hand, presence of electron releasing group such as alkyl group do not favor the formation of phenoxide ion, resulting in decrease in acidic strength. That's why acidic strength of 2-methylphenol is less than 4-methylphenol, which is less than 3-methylphenol. The third one is esterification. Phenols like alcohol react with carboxylic acid, acid chlorides, and acid anhydrides to form ester. Consider the reaction C6H5OH plus R-COOH in presence of H plus gives C6H5O C double bond O R dash plus H2O, where C6H5O C double bond O R dash is ester. C6H5OH plus R-CO whole twice O in presence of H plus gives C6H5O C double bond O R dash, which is ester, plus R dash COOH, which is carboxylic acid. Consider also the reaction C6H5OH plus R-COCl in presence of pyridine gives C6H5O C double bond O R dash plus HCl. Acetylation. The introduction of acetyl, that is CS3CO group, in alcohols or phenols is known as acetylation. Acetylation of salicylic acid produces aspirin. Consider the reaction C6H4OH COOH at ortho position plus CS3CO whole twice O in presence of H plus gives C6H4 COOH and OC double bond O CS3 at ortho position plus CS3COOH, and C6H4COH C double bond O CS3 at ortho position is known as acetyl salicylic acid, that is aspirin. Let us now understand reactions of benzene ring. The first one is electrophilic aromatic substitution. In phenols, the reaction that take place on the aromatic ring are electrophilic substitution reaction. OH group attached to the benzene ring activates it toward electrophilic substitution. Nitration reaction. With dilute nitric acid at low temperature, that is 298 Kelvin, phenol yields a mixture of ortho and para nitrophenols. Consider the reaction C6H5OH in presence of dilute HNO3 gives orthonitrophenol and paranitrophenol. Text. Orthonitrophenol is steam volatile due to intramolecular hydrogen bonding, while paranitrophenol is less volatile due to intermolecular hydrogen bonding, causing the association of molecules. With concentrated nitric acid, phenol is converted to 2,4,6 trinitrophenol. This product is commonly known as picric acid. Consider the reaction C6H5OH in presence of concentrated HNO3 gives picric acid. Text. As yield of above reaction is low, Nowadays, picric acid is prepared by the reaction C6H5OH in presence of concentrated H2SO4 gives C6H3OH SO3 whole twice, that is phenol 2,4 disulfonic acid, which in presence of concentrated HNO3 gives 2,4,6 trinitrophenol, which is known as picric acid. Halogenation reaction. When the reaction is carried out in solvent of low polarity like CHCl3 or CS2 at low temperature, monobromophenols are formed. Consider the reaction C6H5OH in presence of concentrated HNO3 gives 2-bromophenol and 4-bromophenol, in which 4-bromophenol is major product. Text. In case of phenol, the polarization of bromine molecule takes place even in the absence of Lewis acid, like FeBr3. It is due to activating effect of OH group attached to the benzene ring. When phenol is treated with bromine water, 2,4,6 tribromophenol is formed as white PPT. Consider the reaction C6H5OH plus 3Br2 gives 2,4,6 tribromophenol. Coal-base reaction. Phenoxide ion generated by treating phenol with sodium hydroxide is even more reactive than phenol towards electrophilic aromatic substitution and undergoes addition of carbon dioxide, a weak electrophile. Consider the reaction C6H5OH in presence of NaOH gives C6H5ONa, that is sodium phenoxide, which in presence of CO2, then H+, gives hydroxybenzoic acid, that is salicylic acid. Mechanism. You can here see the mechanism of coal-base reaction, which is electrophilic substitution reaction. Reactions of benzene ring. The third reaction is Riemer-Tiemann reaction. On treating phenol with chloroform in presence of sodium hydroxide, a CHO group is introduced at ortho position of benzene ring. The net reaction is C6H5OH in presence of CHCl3 and aqueous NaOH gives C6H4O-Na plus CHCl2 at ortho position, which in presence of NaOH gives C6H4O-Na plus and CHO at ortho position, and further in presence of H plus gives C6H4OH CHO at ortho position, which is known as salicyl aldehyde. Mechanism. You can here see the mechanism of the following Riemer-Tiemann reaction, which is electrophilic substitution reaction. The fourth reaction is reaction of phenol with zinc dust. Phenol is converted to benzene on heating with zinc dust. Consider the reaction. C6H5OH plus Zn gives C6H6 plus ZnO. The fifth reaction is oxidation. Oxidation of phenol with chromic acid produces a conjugate diketone known as benzoquinone. Consider the reaction C6H5OH in presence of Na2Cr2O7 and H2SO4 gives benzoquinone. Phenols oxidize to quinones in presence of air also.